Hi, everybody. This is Gigi Drent from Kauai Community College. Today, we are learning about perimeter and area. Let's get started. Okay, so before we talk about perimeter and area, let's talk about what it means to measure, right? So to measure requires a two-step process. One is to define the unit that is being used, and then two is to express the length or the weight or whatever it is that you are measuring as multiples of that unit, right? So length is not just a number, it's a quantity with a magnitude and a unit. For example, let's take a look at this picture here. Okay, the pencil, the length of that pencil is 5 small paper clips long. In this case, the magnitude is 5 and the unit is small paper clip. Okay, now the same pencil, however, is 3 units long if the unit is large paper clip. Okay, so it's very important that you define the unit that you are using to measure before you actually say what the quantity is for that measure. Okay, perimeter is defined as a boundary of a two-dimensional shape. Okay, let's take a look at this rectangle, for example. Now let's define a unit before I measure that perimeter. Okay, suppose my unit is that long, and I'm gonna call that 1 shaka, 1 shaka long, okay? Then the perimeter would be how many shakas is the boundary of that shape. So let's go around and count. That's 2, 4, 2, and 4. So altogether, the perimeter is 12 shakas. Okay? Always keep that measuring process in mind. What's my unit, and then how many? Now, area is defined as the interior space of that two-dimensional shape. So remember, the unit for length was 1 shaka long, right? So the unit for area would be 1 shaka square. Okay, so if the unit for length is 1 shaka, the unit for area is 1 shaka square. So you go and take a look at this picture and say how many of those squares will fit inside this rectangle. So let's take a look. I'm going to draw some lines in so we can count. Okay, so it looks like there are 1, 2, 3, 4, 5, 6, 7, 8 shaka squares inside that rectangle. Therefore, the area is 8 shaka squares. Now, the question I want to ask you is, how did you see and count that shaka squares? Like, how did you see that 8? Did you see it as 2 groups of 4? 2 rows of 4? Or did you see 4 groups of 2? Either way, that defines multiplication. Okay, now why is that important? Why did I just talk about that? Because that's the foundation of why the area of a rectangle is base times height. In this case, 2 times 4 or 4 times 2. And we know multiplication is commutative. That means it has the any order property. So you can switch it. Base times height, height times base is the same thing, right? And that's the basic idea of why an area of a rectangle is base times height. Now let's take a look at some examples. Find the perimeter of this shape. Okay, pause the video, try it on your own. Now, once you have done it, let's check your answer. So it looks like the unit is foot. We're measuring this perimeter using the unit of foot or feet if you have more than one. English is weird. Okay, and then the perimeter is the boundary, and it is a measure of length. Okay, so we're going to go around and figure out how long the boundary is. So let's take a look. 16 on the top, 4 and 4, so the middle part must be 8. That should also be 6, and this should also be 12. So the perimeter is, if you were to walk all around and add them up, would be 68 feet. All right, how did you do? Good job. Now, let's find the area of this shape. Okay, so if the unit of length here is feet, then the unit of area that we're looking for is square feet, right? So we're looking for how many square feet are there inside that shape. Pause and think about how you would count the number of squares inside that shape. Now, once you have done that, you can take a look and check. See if you're thinking as I am. I am thinking that I could draw a line right there, and that's a 3 by 4, so that's 12 square feet. Then the other triangular part is half of that green rectangle there. And that green rectangle is a 3 by 4 as well. So the area of the whole entire green rectangle is 12. So the triangle is half of it, which would be 6 square feet. That means my total area is 18. All right. That's how you count areas, how many squares there are inside. Now, what if you have shapes that are not rectangles? Okay, so you have just seen in that slide that the area of a triangle, I drew a rectangle around it, so the triangle is half, right? So now what if the triangle is not a right triangle like that? Well, here's another visualization for you. See that blue triangle? That still is half of a rectangle. So the area of a triangle is always 1/2 base times height, because it's always half of a rectangle. A parallelogram, the area is also base times height. Wait, how is that possible? Isn't parallelogram slanted? Well, let's take a look. If you have a slanted rectangle or a parallelogram, we define that being the base and that being the height. The height goes from one vertex perpendicular to the other vertex, to the other side, which right here give you the height. Okay. Now, why is it base times height? Well, let's take a look. All you have to do is just move that blue triangular part over, and hello, that's a rectangle. That's pretty awesome. All right, so parallelogram, base times height. And the height is the vertical line dropping from the vertex to the other side, okay? Not the slanted side. Now, what if you have a trapezoid? What's a trapezoid? Looks like that. Okay, the bases are not the same length. Okay, so you have, you can visualize it using two triangles in there, okay? Triangle 1, triangle 2. And if I look at triangle 1, my height goes from here to here, okay? And that's H in the picture. That's H, right? So the area of triangle 1 is 1/2 base 1 multiplied by H, the height. Now triangle 2, since this is my base here, my height goes from this vertex right here, straight down, perpendicular. My height in this case just happened to be outside of the triangle, and it's the same as the height of triangle 1. So the area of triangle 2 is 1/2 base, oopsie, that's a typo right there, base 2 times the height. Now, if you add these up, triangle 1 plus triangle 2, you would have 1/2 H, that's in common. I factor out the H, and then I have B1 plus B2, and that's what that is. Okay, that's pretty awesome. Area of a trapezoid is 2 triangles. So 1/2 base 1 plus base 2 times the height. That is the same for both triangles. Okay. Now, this shape here, and most of us know it involves some kind of pi, right? The perimeter in this case, we call that the circumference, meaning the boundary of that circle. Okay. And the circumference is pi times the diameter, or 2 pi r, and the area is pi r squared. In class, we'll discuss more of the reasoning behind why those are what they are. Okay, but for now, this is what you need to know. All right. So we're going to use these formulas here to find the area of some composite shapes, like this one, okay? I really want you to pause the video now and wonder how you would go ahead and approach this problem. Now, once you have already think about it, let's take a look. This is how I see it. I see the total area of the shaded region being a triangle. That would be this one right here, that triangle. And I also see a full rectangle, that rectangle right there. But then I also see that half of a circle is not shaded. So I am going to subtract out that half of the circle. Okay, does that make sense? Okay, so once you have a composite shape, break it apart, visualize it. How is that shape made? Okay, and what we're going to do is use 1/2 base times height for the triangle, base times height for the rectangle, and pi r squared, but then half of it. So we're going to divide pi r squared by 2 to get half. And once you do the calculations and plug in the numbers, you have that being your area of each one of those shapes. Okay, so then 600 plus 2,000 minus 200 pi, the area of the composite shape is 2,600 minus 200 pi, and the unit is, okay, let's remember what we're counting here. Centimeter is the unit of length, So the unit of area must be centimeters squares. We're counting centimeters squares. And if you use your calculator, use the pi button to calculate the 2600 minus 200 pi, being approximated as 1971.68 centimeters square. And that's how you find area of composite shapes. Okay. What if I am asking you for perimeter? Okay. I'm gonna let you visualize this and try this on your own. I'm gonna leave it hanging on this video. You are on your own here. I will see you next time.